So once again, an exercise in partial fractions. Once again, we have to factor the denominator, and it is x times x squared plus 2 on the bottom. I think you can all see that. And also that x squared plus, well, what did I say? 2. X times x squared plus 1 in the denominator. X times x squared plus 1, which is what I have written here. And furthermore, you cannot factor x squared plus 1 any further. So these are our factors. So let's just go straight to the next step, which is breaking up this fraction into two. One with this denominator and the other one with this. Now comes a difference compared to what we did in the previous two exercises. We now have a quadratic factor in the denominator, which means that the numerator must be a linear factor, not just a constant. The numerator must trail the denominator by 1 degree. So if this is square, the numerator can be linear. So we must allow for that. So we're going to denote this unknown coefficient by a. But what goes on top here is bx plus c. So when I have 3 unknowns, and I'm hoping that we won't run into too complicated of a linear system with 3 equations and 3 unknowns. So we'll see how it unfolds. So I'm once again taking this offline, okay, and just multiplying it out. When we combine these two fractions in the sum, in the denominator we have just what we want. So I'm not even going to worry about the denominators. In the numerator, we'll have a combining like terms. Ax squared plus bx squared. So it's a plus b x squared plus cx, that's the only linear term, plus a. And so now I'm confident that I'll be able to pick out everything I need from this one by one. Because this quadratic polynomial must match this polynomial right here. So I know from here that a must be 12, because that's the free term over there. C must be 6, because that's the linear term there. Okay, and a plus b must be 0, because there's no quadratic term there. And if a is 12, then b is minus 12. Okay, so here we actually won't be completely out of the woods, having plugged this in. But let's do that. And again, if I were doing this on a piece of paper with a pencil, I probably wouldn't make this a separate step. I would probably just erase a, b, and c here and plug in these coefficients. But just so that we have a record on the board, here's what we have. And from this point on, you should actually be able to just write out the solution. Now, I appreciate that this is somewhat complicated. You guys are with me on that? It is a little bit complicated, but I still think you'll be able to do this. So let's do it together. There's no question about this. This is 12 natural log of x. Here, there's no choice but to break up the numerator. The 6 divided by x squared plus 1 will be my beloved arctan. So let's put that here. And there's a reason I'm going over this relatively fast. This is precisely the sorts of integrals we've been working with for the last couple of weeks. So then here, focusing on just minus 12x divided by x squared plus 1, my IC is 1 over something. Because the derivative of that something, which is 2x, is right there. So it's 1 over x squared plus 1 times the derivative of x squared plus 1, that chain rule signature, which is 2x, except I'm minus 6 times that. Instead of having 2x, I have 12x. So it's minus 6 times the log of this quantity, plus constant.